In this video, we're going to learn a technique called completing the square that can be used to solve quadratic equations. But before we dive into that method, I want to show you a couple of other things first. So let's just start by talking about how we can use square roots to solve equations. If I have the equation x minus 3 squared equals 25, I can get rid of that squared by taking the square root of both sides. Now I do have to put a plus or minus there to indicate that whether you square a positive or a negative number, you end up getting the same thing. So taking the square root gets rid of that squared, and I have x minus 3 equals plus or minus root 25, which is 5. So I can actually write this as two separate equations. X minus 3 could equal 5, or x minus 3 could equal negative 5. And then I can add the 3, and that gives me x equal 8, or x equal negative 2. So I think the important thing here, easy mistake to make, is don't forget that plus or minus. The kind of second important thing to remember with this type of problem is before you can take the square root of an equation, you have to make sure that the quantity squared is by itself. You have to isolate the squared quantity. And so if we look at my second example, 2x squared minus 8 equals 0, if we want to use the square root to solve this, we have to get the x squared by itself. And so that actually means add the 8 and then divide by 2, and that gives me x squared equals 4. Then I can take the square root of both sides, don't forget the plus or minus, and so x equals plus or minus 2. So our goal when we're completing the square is going to be to get equations that kind of look like this, equations that we can use the square root on. In other words, our goal is going to be to create what we're going to call perfect square trinomials, things that can be factored as something squared. And so to help us do that, I want us to recognize the pattern that happens when we expand each one of these binomials. So if I were to multiply out x plus 2 times x plus 2, first would be x squared, then I would get a 2x, and a 4. And if I combine like terms, that's x squared plus 4x plus 4. Now the pattern that I want to point out is notice that the 4 comes from taking 2 plus 2, and then the constant 4 came from taking 2 times 2, or 2 squared. And so that pattern is going to hold in the rest of these. For example, if I were to square x minus 4, I should get an x squared, and then negative 4 plus negative 4 is negative 8. So the next term would be a negative 8x. Negative 4 times negative 4 is plus 16. So another way of thinking about this pattern is the negative 8 is actually 2 times negative 4, and the 16 is negative 4 squared. All right, what about x plus 6 squared? Using the pattern, I would get x squared plus 2 times 6 is 12, 12x, and 6 squared is 36. So in general, this pattern is, let's see, if you square a plus b, you should get a squared, and then whatever 2 times b times a is, and then your last term will be b squared. So it's kind of your basic pattern, and I'm going to call each of these expanded solutions, each of these trinomials here, we are going to call perfect square trinomials because they can be factored as something squared. And so that's going to be our goal, is creating perfect square trinomials. So let's try to do that next. If I give you the first two terms of the trinomial, we're going to try to figure out what does that third term have to be so that this is a perfect square trinomial. So basically, to complete the square, we are always going to take the number in front of the x. In this case, it's 14, and we are going to divide that number by 2. 14 divided by 2 is 7. Then we take the 7 and we square it, and that gives us 49. So to complete the square, again, I take the number in front of the x, it's 14. I divide it by 2, that's 7. And 7 squared is 49. So I would have to add 49 to complete the square. This can be factored as x plus 7 squared. 7 plus 7 is 14. 7 times 7 is 49. Okay, so let's take a look at another one. X squared plus 12x. If I want to complete the square, I take the number in front of the x, it's 12. I divide it by 2, and that gives me 6. Then I take the 6 and I square it. That's 36. So to complete the square, I have to add 36. This can be factored as something squared. It can be factored as x plus, and it's actually always the number that you squared. So x plus 6 squared. And you can check 6 plus 6 is 12, 6 times 6 is 36. All right, one more like this and then we'll put all this together. So if I want to complete the square and I have x squared minus 5x, I take the number in front of the x and I am going to ignore the negative right now and deal with that later. So I take the number in front of the x, it's 5, I divide it by 2, and 2 does not go into 5 evenly. We want to work with fractions instead of decimals. It's going to allow us to simplify our answers later. So I'm going to say 5 divided by 2 is just 5 halves. So I take the number in front of the x, I divide it by 2, and then I square it. 5 squared is 25, 2 squared is 4. So to complete the square, I am going to add 25 fourths. This can then be factored as something squared. It's going to be x, and this is where I'm going to use the negative. You just keep the sign. If it's a minus, you make it a minus. And it's always whatever you squared. So it should be x minus 5 halves squared. So finally, we're going to put all of this together and try to solve equations using the method of completing the square. So the first thing we're going to do is move the constant over. And so if we look at my example, that means move the 7 over, or add 7 to both sides. So that's going to give me x squared minus 8x, and I'm going to leave some space, equals 7. So that's step 1. Step 2, I complete the square. So I take the number in front of the x, I divide it by 2, 8 divided by 2 is 4, and then I square it, and I get 16. So to complete the square, I have to add 16, and I have to do that to both sides. This is an equation. Whatever we do to one side, we have to do to the other side. So that's step 2. Step 3, I'm going to factor. This can be factored as something squared. I keep the sign, it's a minus sign. And it's always whatever you squared. So x minus 4 squared. And then 7 plus 16 is 23. Now I have something I can solve with that square root method. I'm going to take the square root of both sides. Don't forget the plus or minus. And I get x minus 4 equals plus or minus root 23. And root 23, that's not a perfect square. There's nothing we can do with that. And so to finish, I'm going to add the 4. But we can't actually combine the 4 with the root 23. They're not like terms or like radicals. And so I'm just going to write my answer as x equals 4 plus or minus root 23. All right, here's my next example. X squared plus 5x minus 3 equals 0. So step 1 is move the constant over. In this case, that's add 3. Step 2 is complete the square. So I take the number in front of the x, I divide it by 2. 5 divided by 2 is 5 halves, and then I square it. 5 squared is 25, 2 squared is 4. So to complete the square, I have to add 25 fourths, and to keep my equation balanced, I have to do that to both sides. Step 3 is factor. We can factor this as something squared. It's going to be x plus, it's always whatever you squared, so x plus 5/2 squared. Let's see, now I need to add the 3 with the 25/4. I'm going to need a common denominator to do that. 3 is the same thing as 12/4, and 12 plus 25 is 37, so 3 plus 25/4 is 37/4. All right, now we can get rid of the squared by taking the square root of both sides. Don't forget the plus or minus. That gives me x equals x plus 5/2 equals plus or minus. And 37 is not a perfect square, so it stays inside that radical. But 4 is a perfect square. And square root of 4 is 2, so that's just going to turn into a 2. Finally, to finish this problem, we are going to subtract the 5/2. And so my solution is going to be x equals negative 5/2 plus or minus root 37 over 2. Those aren't like radicals, so I can't really add them. If you want, you could combine it into a single fraction because you happen to have the same denominator, but you don't have to do that if you don't want to. Now, this problem is a little bit different than the ones we just did because there happens to be a number in front of the x squared. And unfortunately, completing the square only works if there isn't a number in front of the x squared, or there's a 1 in front of the x squared. So what that means is if there's a number in front of the x squared, you just have to divide it out. You have to divide everything by that number. And in this case, that gives me x squared plus 7/2 x minus 2/3. I think I said that wrong. X squared plus 7/3 x minus 2/3 equals 0. And so the problem's going to be a little bit uglier, but the good news is we use the exact same steps. So step 1 is move the constant over. So x squared plus 7/3 x, I leave some space, equals 2/3. Step 2 is complete the square. I take the number in front of the x, it's 7/3, and I divide that by 2. Dividing by 2 is the same thing as multiplying by a half. Some people might have learned this as like copy dot flip or multiply by the reciprocal. And then you just multiply straight across and you get 7/6. So we take the number in front of the x, we divide it by 2, and we square it. 7 squared is 49, 6 squared is 36. So I have to add 49 over 36 to both sides. Okay, step 3, I factor. This is going to be x plus something squared. The something is always whatever you squared. And then let's see, we have to figure out what is 2/3 plus 49 over 36. I need a common denominator to do that. So 2/3 is 24 over 36. So this equals 73 over 36. All right, almost done. To finish this, we take the square root of both sides, and that gives us x plus 7/6 equals plus or minus. 73 is not a perfect square. It stays under the radical. 36 is a perfect square. We take the square root of it. So finally, we're going to subtract our 7/6, and we are left with negative 7/6 plus or minus root 73 over 6.